Hey, my name's Marcus Burton. I wanted to just share a couple of perspectives, excuse me, a couple of perspectives about the relationship between 5G and Wi-Fi. And I think there's probably a lot of myths and misconceptions that go around this. So I want to just kind of tackle the ones that I hear the most. And the very first one I think is the most important because it's sort of the framework by which we compare these things and think about these things, which is really all about timeline. So, there's a lot of Wi-Fi 6 versus 5G comparison. You all know how 802.11 develops, these PHY specs every 3 or 4 years. The Wi-Fi Alliance picks them up in phases or releases. And it lasts for 3 or 4 years as a generation, and then something new comes along. 3GPP with cellular does the same thing, but they have releases, and those come out about every 12 to 18 months. And those releases are bundled up, sort of roughly speaking, into these generational packages like 4G and 5G, which last about a decade. So the first problem is Wi-Fi as an industry doesn't really have a bundling mechanism for the 10-year sort of future of Wi-Fi as a whole. So we get, these 3 or 4 year chunks at a time, and there's not a whole lot of vision beyond that. So we compare the wrong things when we talk about 5G versus Wi-Fi 6. 5G versus Wi-Fi is fine, or Wi-Fi versus cellular is fine, but let's get the timelines ordered up right and think about these technologies in an aligned way. The second one is sort of the way that we think about the 5G technology and market, which is that you can basically subdivide 5G into 2 categories. There's sort of macro, and then there's like the micro or the private space. The private space is basically what's deployed or operated by enterprises. But there's a lot of sub-markets within this space. So this space will actually be bigger than Wi-Fi eventually. But there's a lot of sub-components to it that don't necessarily compete with Wi-Fi just because it's in the enterprise. So there's DAS replacement for neutral host. There are solutions that replace voice. There are IT and IoT solutions. There's fixed wireless access for wireless WAN connectivity to enterprises and residences as well. So this is really just to say that there is actually some competition in here. There are slices of this sub-market that compete with Wi-Fi, which is really the third misconception. So we all know the telcos sort of came out and said 5G is going to kill Wi-Fi, which is just stupid. But I think there was a counter reaction within the Wi-Fi industry, which is someone said, no, these things are complementary. And we're all sort of yeah, they're complementary, they don't compete, which is not really the truth. It's a partial truth, but they're actually complementary and they're competitive at the same time. So there are plenty of technologies that are deployed on Wi-Fi today where enterprises, by and large, are evaluating cellular to potentially replace Wi-Fi for this. So there's a lot of back-of-house applications, POS, voice, robotics, all of these things that could be deployed on Wi-Fi are being evaluated by cellular. So I think there's actually a middle space here where instead of sort of burying our heads in the sand and saying these things are just complementary, they're actually competitive as well. So it actually sort of puts a little bit of burden and pressure on us to say why is Wi-Fi better, and actually get to know cellular and what benefits it has. So maybe just to jump into that, one of the misconceptions is that because Wi-Fi has been deployed in enterprises, that 5G or cellular as a whole needs to become like Wi-Fi. There's a partial truth to it again, but cellular actually brings strengths as a technology that Wi-Fi doesn't have. So it does coverage really well. Partly that's just a function of spectrum and a function of transmit power, but it's also a way that cellular is designed as a carrier. It does mobility well. It does application determinism really well, but it has what I think of as sort of unforgivable sins. So there is a truth that's 5G needs to become like Wi-Fi. And if you go to a private 5G conference, they'll say this over and over. We need to be more like Wi-Fi because Wi-Fi has these great strengths, it's easy to use, it integrates well with sort of the Ethernet and IP infrastructure, it's easy to manage, the costs are managed, the spectrum is easy to understand, all these things are great. But Wi-Fi has its own unforgivable sins, and guess what? They just so happen to be the things that cellular is really good at. So, again, this is why we spend so much time on design, on troubleshooting of Wi-Fi, because we're asking it to do things that it really wasn't designed originally to do, but it's been sort of manipulated over time to do these things. So this is where I start to see, as an industry, we need to put more pressure on the development of Wi-Fi 7 to actually start to do some of these things well, to deliver better application SLAs in terms of low latency, in terms of managing the QoS requirements of the application as well. So actually there's partial truth here as well. And so oftentimes what people will say is that these things are going to converge because they'll both be deployed in the enterprise and they'll just kind of map together over time, which is kind of true and kind of not true. So the misconception is usually the way that they'll converge. So people think that let's just smash these two technologies together. The elements that will converge are the experience elements. So in the past, we've basically, the last decade, let's say, we've integrated or unified wired and wireless. Lots of drive-by vendors to do this. I think the next decade will be integrating wired and wireless, where the second wireless is, the private 5G, as well as other technologies. I mean, the LoRa integration, that becomes a part of this as well. The tools and the management process, the visibility, the policy, the way that you think about all that, as well as the platforms that you deploy on. So you want to manage in one cloud layer. You want to deploy the on-prem pieces on one edge platform layer, the route to market, the way that this stuff is sold into the enterprise through partners and through channels and through system integrators. Those things will actually start to converge, but what won't converge is actually the first thing that we all think of. Put these two radios in the same box, right? But because, let's just take CBRS as an example, different spectrum, different coverage, different deployment model, different use case. You deploy them in different places at different densities for different use cases with different designs. So the sort of the motivation to put these two radios in the same box, it doesn't add up because, especially if you think from a customer lens, the 5G radio costs a lot of money. So from a vendor perspective, it's like if you're going to put that in a box, you're going to get that money back somehow, right? So you're going to sell it for a higher price, and customers are like, well, I don't want to pay that extra price for all of my Wi-Fi radios when I'm only going to turn this on in a quarter or a fifth of them. So this is one of those things that won't converge. The protocols will never converge. They might share pieces from one another, but they won't actually converge together. So just put that aside if you do. The sixth one is really the same way that we talk and think about Wi-Fi. I bring this one up because it's important as, let's say, non-cellular experts. Some of you all might be, but I know many of us that came up through the ranks of sort of the enterprise and Wi-Fi and IP are not cellular experts. So the ITU comes out with requirements for sort of 5G technology, and then 3GPP develops to those requirements. And these are some of the requirements. There's a bunch of them, but these are just some of them. So download peak data rate, 20 gigs, uploads 20 or 10. The user experience downlink data rate, this is like the way I think of the peak data rate is like what people put on their LinkedIn profile, and the user experience is like what they can actually do. So this is a little bit like that. It's what it can actually do, or what a single user actually experiences. Latency, 1 millisecond. So if you're paying attention to this space at all, you'll hear these numbers thrown around all day long, and 1 millisecond latency all day long, and it's just so frustrating because it's not realistic, both in terms of what it can do today, but even when it does do it, you have to change the way that you think about and design these networks all around. So let me just give you a quick comparison. What if I told you 802.11ax or Wi-Fi 6 can do 9 gigs per second, right? You should throw things at me, right? Because even though the spec says it can do it, what it takes to get there is so unrealistic that no one here that's reasonable actually says that it can do these things. And yet in the 5G space, you hear this 20 gigabit per second or 1 millisecond latency thing all the time. The other thing that's important to understand is the way that 5G has basically expanded the spectrum use of cellular. So it was always sub 6 gigahertz in the past. But with 5G, they've gone up and said, let's do a high band as well. So anything above 6 gigahertz, including millimeter wave, which is basically a way to say, look, there's all this spectrum that's available up above 20 gigahertz. Why don't we use that spectrum? And then it's a lot easier to achieve this 20 gigabit per second data rate. And the same way that 802.11ad and AY did is like, how do we accomplish big data rates? Or like when we set out as 802.11 to define a new spec and say, we need to hit a new goal, let's hit that goal. What's the easiest way to do that? More spatial streams, wider channels. So in 5G, you can actually do 1 gigahertz and bigger channels. 1 gigahertz. So we say 160s are bad. 1 gigahertz channels. You need millimeter wave to hit any of those goals that are driven by these high speeds. And then the final one is also, there are elements of cellular technology that I think are more compelling than Wi-Fi. The scheduled and coordinated nature of the access medium is more deterministic. There are benefits, but it comes at a cost, a literal cost. So if you look at, if you're a device manufacturer and you're going to say, we're going to put a we're going to put some wireless connectivity in our device, and we want to manage the cost of our device, and we want to also build it in a way that customers will use it and adopt it. Say we could do Wi-Fi with BLE, and it costs like $250, $270. These numbers are like before sort of the supply chain crunch, so these are probably more closely aligned with like real market numbers instead of like the chaos of today. The front end componentry that goes with Wi-Fi costs, another extra couple dollars. The 5G chip costs $25, which might not sound like a big deal. I mean, obviously it's a 10x difference, so it's big. If you want millimeter wave, all the extra front end stuff to do millimeter wave spectrum to support those bands is like another $25. So you're talking about $50 to hit any of those high-speed goals in a client device. Now, if you want to sell that device to enterprises for, let's say, $200, $300, $500, put it in a laptop, like these companies they control their margins. I mean, the previous vendor that I worked at, we would have fights over 12-cent parts, whether you're going to put that in the AP or not. So, when you're talking about a $50 cost adder in your electronics, I mean, this is a tremendous amount of money. So this is a huge delta in terms of just getting adoption of 5G into client devices so that it could even ever have a chance of being competitive or replacement for Wi-Fi in an enterprise at large. So you'll see adoption in more specific purpose-built devices that are more expensive to start. Or you'll see the prices go up on those devices. And then the final thing is just really this drives adoption rates. So just one data point, and this comes from like forecasts out to 2024, I think, which is the number of laptops that'll have Wi-Fi, they all do, versus the number that will have 5G, 2%. So just some thoughts, some insights on 5G. Thanks again, everyone. Appreciate it. Good to see everyone. Nice.